Thanks to the Talk Python team who sponsored this episode of the Engineered Mind podcast. If you want to learn Python and delve into exciting topics like data science, web development, or building apps, feel free to visit talkpython.fm/mind to find your next level and get a 10% discount. Also a big thank you to all my patrons who support the Engineered Mind podcast. Hi and welcome to the Engineered Mind podcast. In this podcast we cover topics such as engineering, artificial intelligence, neuroscience and other interesting topics to educate, inspire and engineer people's minds all around the world. I'm your host Yusuf, and for this episode of the podcast I'm extremely excited to have Goku Mohandas on my show. Goku is currently an AI researcher and advisor in the health space. He was more recently the head of ML at Ciitizen and worked on natural language processing applications for several years at Apple before that. He has also been involved in democratizing education through blogs, technical publications, courses, and more recently, the Made with ML platform. In this podcast, we talked about Goku's platform Made with ML, the education system versus his approach of learning new things, if a computer science degree is required in artificial intelligence, tips on how to get started in AI, his thoughts on artificial general intelligence, how to read papers, and much more. For updates on upcoming podcasts, projects and videos, make sure to follow me on Twitter as well as on Instagram. To join my weekly newsletter engineeredmind.sh, where I share exclusive content, visit yusuf.substack.com. And now, ladies and gentlemen, here's my podcast with Goku Mohandas. Goku, it's an absolute pleasure to have you on my podcast, and finally we found the time to meet in the podcast. What we want to start with is, I saw that your background is in health and medicine. Can you talk about that a little bit and what you did before graduating?
Yeah, no, absolutely. So there was a brief period while I was working where when I was at Apple that had nothing to do with health. But my background is, you're absolutely right, it was in healthcare. My undergrad, I did chemical and biomolecular engineering. And then a lot of my research in undergrad and master's was in health. Undergrad, it was more wet lab. So, the only programming we did was with MATLAB. Didn't even know about Python. But a lot of it was in the wet lab setting. So, we'd work with, titrations, diffusions, things like that. I did a lot of work with nanomaterials for drug delivery. And then in the master's, it was getting a bit more technical in the sense of using computer science. So it was combining health with, machine learning had just started to become popular again. This is around 2014, 2015. So it was combining the health background I had with the machine learning frameworks that were coming out. Scikit-learn was already there, but TensorFlow came out end of 2015. Theano was still being used, but it was about combining both of those together to really do some cutting edge research. I can talk about specific examples if you want, or if you were thinking something else.
Yeah, sure. You can talk about some examples if you like.
Yeah. So usually when we say health research, people always think, the canonical example of looking at X-rays, trying to say, or looking at mammograms and trying to say, is there a tumor here or something? That does happen, but those applications, they're kind of dated. People have been working on those specific computer vision tasks for close to 2 decades now. And the machine learning that's trusted and used in hospital and clinical settings are those traditional computer vision tasks. But on the research side, people are still doing research on computer vision on X-rays and MRIs, but now there's a lot of research done on text, multimodal data like time series. And we get time series from everything now, right? Down from your smartwatch to all the different ICU sensors. So there's a whole new subset of data that's actually being collected, thanks to sensors, and actually being used for task related outcomes. So I think now the type of research that I worked on is about using the text to try to get things out. And you and I are fairly healthy. We may generate maybe 5 to 10 pages of documents a year, health documents. We can read through easy. But when someone has an illness, especially let's say a cancer patient, they're getting treatments every few weeks. And those treatments are all based on sometimes hundreds, if not thousands of pages of documentation. And it's not just one doctor, right? we have a general physician, but they'll have a doctor, a radiologist, an immunologist, an oncologist, right? Everybody's looking at different parts of, let's say, their malignant tumor or something. They're generating lots of reports, and it's all important. So NLP really plays a big part here because nobody has time for every single patient to look through all 1,000 documents. And actually, when someone physically looks through it, and let's say they're tired or they don't have time, there's a lot of error that gets introduced into this. I actually, the company that I worked at after Apple, the CEO's sister passed away from breast cancer as a result of this large amount of data that the nurse practitioners and doctors had to go through. So NLP in health is really about, it's not about making a decision saying, hey, with this input, it's this output. It's more with this text, here are some of the interesting aspects that the doctor should focus on, right? So now instead of looking at 1,000 pages per patient per month, the doctor or a nurse can only has to look at maybe 1 or 2 pages, right? It's about sort of generating that profile, that summary report with all the important things, and then making the treatment based on that. So it's not about making a decision; it's more about augmenting the physician's decision. So that's a lot of research that I've been doing. Just to name particular things, it's not just about representing the text, but representing the entire patient visit. So you look at all the drugs that the patient took, the symptoms, the outcomes, and you encode all of that into, let's say, a patient vector. And now you have patient vectors for different visits. Now you can put all that together to predict some outcome, for example. Or you can even do things like named entity recognition. And, yes, it's useful to pull out drugs and symptoms and stuff like that. But now we're starting to see a subset of NLP in health focused on extracting entities from text and then relating it, because so much of what we know about drugs and symptoms, it's based on previous studies. But there's, humankind, there's so many different types of people. You don't know how any one person is going to react to something. So by pulling out these entities over time, we can start to create these ontologies and say, okay, this drug, yes, it gives these 10 symptoms, but it gives these other 2 symptoms if you're this type of person who took this type of drug. So we're able to create all these nuances now and really start to map the medical world. And that's growing a lot. So yeah, that's what a lot of my research was focused on. I had a lot of fun because it was not just, publishing papers. In fact, the focus was not publishing papers at all. Our focus was, let's do the research, let's use existing research, let's do some our own novel research. But how do we get this in the hands of actual clinicians, right? How do we get it used? How do we get it used? And at that point, performance is a big deal, but not the biggest deal. Mm-hmm. We care more about things like interpretability. A doctor will use an 80% model with great interpretability any day over a 95% model, right? Because if there's no evidence, why will they use that, right? So a lot of the focus was on making it actually focus on how the doctors operate and what they care about more than performance. And it wasn't just about putting out papers. It was about making the products for the clinicians. And I think I was lucky that the colleges had, clinical workplaces. That relationship was already there. So it was easy to have that feedback loop instead of just, doing research on your own in an isolated environment. It's good to have that exposure with the real world use cases.
Mm-hmm, got it. It's so cool what you're working on, Goku. Would you say that this is somehow your mission, to use AI tools to help people all over the world?
Yeah, so that's very general, right? But I think I've always had that perspective. When I was working at the health company, I was one person, mm-hmm. and I was, I go to work every day. I make some things with the team. We're helping patients. So that's helped me. I'm one person with one team helping one group of people. So then what I started to do, this was the end of 2018, I used to teach while I was at Apple and startups on the side. So I worked with O'Reilly Media, like blog posts, video series, and textbook. And everything was always behind a paywall. You had to pay something. And I decided after those contracts ended to release a lot of my code that I produced. And I put it up on GitHub, and I saw it pick up a lot of traction. And I had people, I think most people are using ML for common things in the industry, like advertising, finance, and stuff. But I had a few emails, maybe about 10 different emails over the year about people using it for industries that I didn't know anything about. So they took my course and they built things with anti-poaching, fashion, obviously in the healthcare space because I had a little bit of focus on that. But I started to see people use my course, which was just basics, right? And it's called Made with ML Lessons on GitHub, just the basics. And then that inspired them to take more courses and then build something that, some of the tools they built are being used by the government. So I think that impact that I saw, my little thing could have this much impact. I decided at that point, when it comes to teaching and giving resources to people, I'm not going to make money from that. I'm not going to charge for that. And after I decided to do that, a lot of people started, when it's free, you have a lot more exposure, and people started to build things with it. So my goal has always been to build, whether it's individual tools or entire platforms that allow people to build things on their own. So, you come here, you learn something, and then you use that to build something on your own. And the only payment I ask for people is, whether it's mentoring or whatever it is, you do the same for somebody else later. Once you're done learning, you have to teach, you have to build and give back to the community, because that cycle is how we get better content, right?
Absolutely.
And just, I have to say, I saw a lot of your content a couple days ago, on sort of the traditional engineering, physics, Navier Stokes, things like that. I think it's phenomenal because people always think, oh, this has been around for centuries. I don't need to explain it anymore. That's wrong. The reason I struggled, or so many people struggle in school, is because the textbooks or the medium was not the best resource, right? So absolutely explain some of the foundational things, and the medium that you've taken, good visuals, not too much, not any jargon, right? Cleanly explaining things with simple terms. That combination, I think we need a lot more of that. I think everything that I ever learned in school and in college needs that kind of transformation, because I had a tough time learning, just listening on the blackboard, So I think creating those types of mediums are very powerful for education.
Thank you so much, by the way. I think you do the same with Made with ML. We'll come to that in a minute. And I think you're completely right. It's kind of, when you're in school or in university, it's kind of regurgitating.
Yeah.
You learn for marks, and then you identify yourself with the marks. Hey, I have an A+, I'm better than you. And I think that's not the way to learn.
It's horrible. I mean, if you want to talk in machine learning terms, the objective function is flawed, right? It's why am I learning? Actually, I'm not even learning. A lot of people don't learn because they just try to memorize and pass that next test, right? And that's horrible. I wish I could go back and just take my time and properly learn the foundations. I had to do that later on. Outside of school, I finally like learning, right? So, big disconnect, Yusuf. I think we can talk about this topic if you want, but the traditional sense of college, go 4 years, pay some money to learn something that everybody learns. I think that's going to change. Maybe in another 10 years, 15 years, I imagine a place, and you're not going to only go to college when you're little, right? When you're 20. You can learn anytime in your life. You go to a place or online, you learn about a specific tool and you become good at it. Now you go build something. So I think that continuous learning, that's something that we're starting to see. So, don't let 4 or 7 years of your life in college define what you do your whole life, right?
Yes.
Because it's such a short period of time. You keep learning, keep changing. Don't be afraid to just completely flip what you know and try new things.
That's so cool that you say that. That's so cool that you say that. I think it will motivate a lot of people, and I take the same approach. How was it for you, by the way? You don't have a background in computer science. How? I think it would also be great to motivate people, to tell them, hey, you don't need a CS degree to go into an AI ML.
It's very different now, right? I wouldn't have said that 20 years ago, but now I have a little brother. I tell everybody, don't get a computer science degree unless you want to do research on computer science. Don't get it because there's so many free resources. It's one of the easiest things to learn because of so many resources. So instead, focus on an industry, focus on a niche, right? Health, civil engineering, material science. Pick something that's very interesting, because computer science is no longer an industry, it's a tool, right? So just like Excel or this phone or this pencil, it's another tool that you're going to use. Right now, within engineering, maybe 80-90% of engineering needs computer science. So at that point, everyone has to learn it anyway. And then in the future, I think even more professions are going to need computer science. So don't major in it. And if you did, it's great. You know, you have a great lead. But if you didn't, it's not a disadvantage. In fact, I think it's a big advantage if you know what's something. If you already know an industry really well, right? Because right now it's so saturated. The industry is so saturated. You can't just get away with being a really good coder. You need to be a really good developer in a specific area, right? There's a lot of people in the world, so that's how you need to differentiate yourself. So if you don't have a computer science degree, not a big deal at all. You can learn it. Great resources are out there, free and paid. Takes a couple months, and then you keep learning. It's not just you learn and stop. You keep learning, but focus on your industry. That's the contribution you're going to make to the world, right? So that should be your major.
That's super cool advice, Goku. Thanks a ton. Still, people are also motivated because of they see so many people rising and they're super good coders. They code. You heard these stories, on Twitter. I started coding at 7 or 10, and then they're demotivated because they're already almost in their 30s or 40s. What would you tell them? How can you get into AI, coding, etc.? How did you do it?
Yeah, good coding practice, like clean code. First of all, I'll tell you guys this: you don't learn those practices in school either. Right, like clean code or actual like even GitHub, right? You don't learn that in school. So how the people that are really good, how they learned it, the secret is they learned it from other people. So that's how I learned it too. If you think of the traditional ML PhD researcher, their code is usually not great. It's very dirty. It does what it needs to do, and that's their focus. So that's good. But when you need to share it or when it needs to go to production, it's not that neat. So the way I learned is I found really good mentors. I learned from them. So how do you meet these mentors? My advice would be, let's say, for example, you're focused on NLP in machine learning. Okay? Maybe you even care about health and NLP. So first, learn about it, spend a week or two, learn about the industry. And then you need to find a mentor soon. And you can't just get a mentor randomly. So what you have to do is, as you're learning, release some of the work that you're doing. Make a video, make a GitHub repository, make a little project. When you put that on Twitter and Reddit or Made with ML, when you release things to the world, people give you feedback. Some people will criticize you. Some people will give you good and bad criticisms. Some people will help you. And that's how you meet someone slightly better than you. And then you keep doing that and you meet people better than you, and you learn from them. So I think the biggest mistake that people do, whether young or old, is they just stay in their bubble and they learn for weeks or months and just keep coding on their own. Big mistake. Do something for a week or two, put it out there, get feedback, and then come back after a week. And then you keep repeating that. You have to share your work because you're not going to learn anything because you didn't know it in the first place, right? So you need to put it out there and learn from other people. So that would be my advice. You don't learn it in school, so you have to. This is the only way to really do that. And keep exploring, look at other people's work, re-implement it. There's a lot of books have really good code now these days, and a lot of GitHub repositories are getting better. So I think as a whole, the quality is going up. So the more the content you're seeing is going to be better.
Cool. Obviously, there's a plethora of resources available. So it's kind of a bit of overwhelming. What would you say? What resources did you use? And would you say, because you did, as far as I know, the PyTorch course with the creator of PyTorch?
Yes.
That's really cool. I saw some clips of it, so not everything. Would you say that's a good start to get into AI?
So actually, that's a good question. I would suggest a couple of things. So getting started with AI, I think you need to spend some time learning the basics, right? Before you can get into, the latest stuff or even industry specific things. So on Made with ML, we have a page called Topics, and it's basically a list of collections, and you can go through it in order. It's a list of collections, the best resources, not from today, but from the last 4 or 5 years that have been kept up to date, the best resource for each of the topics. So we start off with, Python, right? So I think it's good to start with a programming framework or programming mindset, because everything you learn, you can quickly test out. If you're just reading about linear regression, for example, for 2 days, it's kind of just theoretical in your head. If you can code it, it's another way to solidify it, right? So you read it, you code it, and then you try out new things. So I would say check out Made with ML. We can put the link up, but madewithml.com/topics.
Yep.
And start in the beginning, Python, and you go in order. It says Python, NumPy, Pandas. Then we get to linear regression, logistic regression, and we keep going. And then after you don't do the whole page. Do go from Python to maybe regression, or if you want maybe MLPs, right? So do that initial set, then work on a project. Work on a project, find a data set, try to put something together. And I'm actually going to be making videos on, after I learn something, how do I make an end-to-end project? So I'm going to release that in a week or two. But work on a project, release it, then come back and learn some more, right? So everything on that page, it's not stuff some of it is stuff that I made, but most of it is by people that are amazing. This is why I built Made with ML, because all this great content I see on Twitter, Reddit over the last 4 or 5 years, I like it or I upvote it. And then 2 weeks later, it's gone. Like I can't find it. Somebody else wants to learn next month. Good luck. You're not going to find that, right? So I wanted to index everything. I wanted to tag everything, make it a project. So now if somebody looks for, best Navier-Stokes implementation, they'll see your video, right? Even though you published a year ago, they should be able to find your video because it's good quality. So that's why I built that. But yeah, that would be my advice. Like, start with the basics there. You can start by topic, or you can take a course. So if you go on Made with ML, you type in course on search, you'll see a list of courses. I would say start with, Andrew Ng's traditional Stanford course. Mm-hmm. If you're looking for something a bit more top down, start with Jeremy Howard's Fast AI, right? Those are great courses. I have my set of lessons, Made with ML, GitHub/Made with ML/lessons. The other 2 courses are fantastic, and that's how I learned. But I take from code first approach. So from print hello world to recurrent neural nets to attention, we go from basics to all the way pure code. And also one other piece of advice: don't just use the frameworks. Do it from scratch first. Yep. So a lot of the things that we teach, even regression or MLPs, we do it from scratch with NumPy first, so you can really understand. After a certain level, don't do it from scratch because it's going to get a little crazy, right? Mm-hmm. I've seen people do crazy convolutional architectures from scratch. It's cool, but at this point, you're just it's a lot of things to keep in your head. So maybe don't do that. But until a certain point, do it from scratch. Once you understand, then start using the frameworks. You'll appreciate it more. Mm-hmm. And then I think the last thing I'll mention about how to get started and keep going with AI. Yusuf, you probably see this every single day. There's so much out there. You see 10 articles, 3 videos, 4 new research papers that people are talking about. Don't read any of it. Okay. Here's what you do. You don't read all of it because it's overwhelming, but don't ignore it because then you're missing out. So what you need to do is organize it into different buckets so that you can come back later, right? So don't bookmark it and put it in a big list because that's noise again. So what you need to do is, let's say we see 4 articles today, one about GANs, right? One about reinforcement learning, supervised learning, and let's say unsupervised reinforcement learning. Okay, 4 different topics. I see 4 different articles. I'm not going to read any unless I need to right now. If I'm working on a project that's related to one of them, I'll read it right now. But otherwise, I'm going to take each of these and put it in different buckets, right? So different folders. Mm-hmm. So this started to get a little messy. So we just released a new feature on Made with ML called collections. You know how on Spotify you have playlists? Yep. So the new Ed Sheeran song, I'll add to my wedding playlist. But Yusuf, maybe you'll add to your European artist playlist, right? So same content, we organize in different buckets mm-hmm. because we're both different people. Yep. So we just released the feature 2 days ago, not publicly yet, it's just a silent rollout. But maybe when you release this, we'll announce it. But when I see an article about GANs, I'll put it in my GAN playlist, my GAN collection. But Yusuf, maybe you'll put it in your generative modeling or your Ian Goodfellow playlist, right? It's different ways of organizing it. So when you see something, triage it, put it away in a place that you know where it is so you can come back later. But you don't have to read it right away because that's way too much information. It's overwhelming. Yep. The brain, we have a certain amount of space. We especially have a certain amount of space for short-term memory. So don't waste that, right? Don't waste it. Instead, store it, right? Computer science term, put a pointer to it so you can come back later. Because I tried I think it was for 1 year, I'd spend 2 to 3 hours a day, woke up early and then at night just reading. I learned a decent amount, but it's very overwhelming. It's very stressful. So I would suggest not to do that. Read what you need to read for your immediate project. Everything else, put away for later. Don't ignore it. Put it away, store for later, because that's how you're going to be able to use it for later and improve.
That's super cool advice. Thank you so much, Goku. Of course, how do you keep yourself up to date? Like, obviously Twitter, because you're very active on Twitter, and maybe you read some papers here and then. What would you do other than that?
Yeah. So I used to use Twitter. I used Reddit. I would also talk to a few people at work. They would have we'll have emails or Slack channels. People would paint articles. Now, I think for the last month, Yusuf, I spend maybe an hour before looking through Twitter and Reddit every day for new stuff. Now I spend 10 minutes on the Made with ML front page. So I used to add a lot of the content and engage with the authors, but over the last month now, we have over 3,000 users. A lot of the authors themselves started adding the projects. We have around 20 moderators now. They add interesting projects. And by the way, it's not just trending projects. We also add projects by researchers from lesser known universities, less publicity, because we don't want to show just influencers' work. Great research is done by people that don't have a great public profile or something, but great research is great research. So we find that, and then we put it on the platform, we highlight it, we promote it. So I spend maybe 15 minutes a day. That's it on Made with ML. I go through the front page. You can see trending. You can also see latest projects, right? So you can see both. I go look through both and I say, okay, if I like something, I'll bookmark it. I'll put it in one of my collections for later. If I really like it, I'll probably read it later that evening, right? And I try to restrict the amount of papers that I read to 1 or 2 a day. And, especially when it comes to papers, don't read the whole thing. Sometimes it could be 10, 15 pages. Don't read the whole thing. Read the abstract. If it's interesting, but you don't need to read it right away, put it in a collection. If it's really interesting, read the abstract. Then I go into, if you already have a background in this, you don't need to read the intro, but read the abstract, go to the results. And then I really like reading the discussion section. That's the part where people are talking about their internal thinking, how they approach this, why they did certain things. That's usually where the meat is. So I go to the discussion and conclusion section after the abstract. So, and then I can get into the nitty gritty if I need to, or if I want to implement it, then I read the whole thing in detail. But just using Made with ML to keep up. And then for papers, I restrict to 1 or 2 a day, no more than 5 or 6 a week, right? So I think that's been my go-to so far. And that's the main reason I built it. I built Made with ML for myself, to be honest. I was wasting so much time and I wasn't seeing all the right stuff. I see a lot of, Twitter's great for in-the-moment discovery and it's a social platform, right? So it's doing what it's supposed to. But I wanted a place where we extract all this good stuff for people to learn from later. So that's why I made this. Get the trending stuff. If I care about some content from the past, I go to the topics page. If I care about other people's collections and curriculum, I go to the collections page. So that's how I've been using Made with ML to keep up to date with machine learning.
Cool. Another topic we want to quickly talk about is ethics and bias. Can you maybe give your opinion on these topics and how important they are?
Yeah. So I would say around 90% of the research that you see, just cruising through Made with ML or Twitter, they don't talk about ethics or bias, and it's because there's nothing wrong with this in the research setting. Because in research, you're trying to perform, some task on some data set and try to increase performance. That's great. But then the moment you take this from research and put it into production, or even like a demo app, you need to think about, as a developer, you need to think about ethics and bias. And I know I'm just throwing those terms out there. There's specific things you need to think about for those two terms, but you need to think about that because now people are actually using your product, right? Whether you work for a big company or a startup, especially if you work for a big company because you have more users probably, you need to think about how it affects not just the people or the points in your training and test set, but think about it, throw out machine learning and computer science. Think about it from a human standpoint. How will my product behave with different types of classes of people that I haven't seen before? Will it be fair? Will it be biased towards certain groups? And so much of that, Joseph, is so hard to say because you don't have the perspective, right? I've worked with people that, they bring, when you work with the different groups of people that have from different backgrounds, they start to say things that where bias could seep in from that you never even thought about. So my advice for people who are learning ML and making projects, in the beginning, try to learn, don't focus too much on that. But when you start to make products for other people to use, where it's just no longer a toy project, talk with other people. And I'll recommend a few people's work, actually. So Dr. Feifei from Stanford Lab, she's done a lot of work with human-centric AI. I think actually today she just joined Twitter's board, which is fantastic because they need that, right? They are the social platform. They're using a lot of machine learning. You need someone like her to think about these things, right? And then there's Rachel Thomas from Fast AI, Ibnit Gebru from Google. These are sort of the pillars of ethics and bias. They've thought about it. They've produced content for this. There's also Nicholas Papernautz's group. They're more on the adversarial learning side, but there is some concept of ethics and bias in some of the work that they do as well. So definitely check out these 4 groups' work. And then when you release something in production, we can talk about this, how industry AI is different from research AI, but one of the things that's so intrinsic to industry AI is the QA. And this is not traditional software QA, but ML QA. It's constantly tested for new types of inputs. Or is the inference data that's coming in, does it match well with the data that we trained with? You're constantly checking for this. Everything is logged. And we have these things called feedback tests and performance tests, not the model performance, but performance of the data similarity. We have these tests pretty much on a daily basis. You get these reports, and the moment you see your model is doing something irregular or being unjust or unfair, you need to try to fix that right away. So it all starts with having a really good initial data set that accounts for a lot, but you can't be full encompassing from the get-go. So you need to have pipelines in place that can capture a lot of this behavior so you can account for it.
Got it. You also worked in NLP, as you told us, for instance, in Apple, right? Do you think when going towards AGI, let's see if it happens in our lifetimes, we don't know. Maybe we know, we don't know. Do you think understanding language is necessary to go towards AGI and to understand humans because it's so fundamental?
Yeah. So I actually haven't publicly talked about this topic ever, but I think so. The first question was, do we need to understand language to have AGI? For that, I absolutely, right? Because that's how we communicate. So we need a medium to understand the nuances of our language and then use that to communicate back to us. So I think that is a requirement, right? That's an assumption that's absolutely needed. So in terms of will it understand language? I feel this is like a little bit of a deep topic, but I think the way artificial intelligence and machine learning understands language right now is fundamentally different from the way that you and I understand language. And I think folks like Geoff Hinton and a few other people hinted at this, and I think it's going to change. But the way machine learning works right now is not the paradigm that's going to allow us to reach AGI. And I'll give you an example. All this new work with transformers and attention, let's say a document is 20 pages. So for folks that don't know, the basic way to explain transformers is instead of just prior to transformers, we had recurrent neural networks, which would look at the tokens or the words right before and after to try to, for some output. Transformers now have a much larger attention span. They can look at words, not just right before, right after, but 2 pages before, 3 pages later. So it's the capacity for attention has increased thanks to the compute and the architectures. So now we're able to use all this extra information to predict something. And I think many people argue that, hey, humans also work that way. As I'm reading the book, I'm processing a lot of stuff and then using that as an output. But I would say the distinction is how we represent the knowledge that's being acquired. The way, with all these recent architectures, it's a it's a computational feat. They're looking through all of this, crazy amounts of attention and convolution, trying to get all that together, put it in a vector representation, and then do something with that. But the fundamental way that we're storing information, I think, is different. There was some work, I think, by Jav Hinton from a couple years ago about how we sort of store these things not as sort of discrete vectors, but sort of pointers to certain areas in our memory. I think maybe something like that could happen, but I think there's a much larger paradigm shift that's waiting to happen that's going to make us step towards AGI. Not to say that the current stuff is not good. I think the way, especially computer vision, right? Just using all the surplus of data and surplus of compute and architecture to extract the meaningful representations from that data, there's always going to be a place for that. Actually, that's what separates us from computers, right? The ability to extract things at that speed and all these unique architectures to predict something using supervised data. Now we can talk about semi-supervised too, or self-supervision. But using this data to come up with this output, I think there's a place for that. And we're starting to see that. All the things that you see in production, it's these machines that are able to capture data at fast speeds, algorithms that are able to process things at fast speeds and get the meaningful representations out of the data and then predict something out of it. So it's the AI that we see right now is not the AGI that, if humans are AGI, it's not the AGI that we're looking for, but they're doing some pretty amazing things that extend our current abilities. So I think for going back to your question, it's not time for AGI yet. I don't even know if in our lifetime, but I think the foundational layer for that AGI is going to look different from the layer that we have for AI right now.
Got it. Do you think in the near future we will do more in terms of unsupervised learning? Because a lot of people discuss if humans learn in an unsupervised manner or supervised manner or even mix. What do you think about that one?
Yeah, so relatively, I guess in the last maybe 9 months or a year, a lot of work on self-supervision. I've always believed this. Actually, when I was doing research at Georgia Tech, we were starting to look at self-supervision. I think that this could be the paradigm shift. Not sure, but it's one of the focus areas that's going to make a lot of the AI tools that we've envisioned possible. And the reason I say that is because in industry, a lot of the bottlenecks are data, right? And even for monitoring pro ML nations like China, where we have a lot of sensors collecting data from everywhere, maybe invasions of privacy, whatever it is, but collecting a lot of data, still the bottleneck is, okay, now you have all the data, but the bottleneck is now labeling that data, right? So unsupervised learning, and specifically self-supervised learning, where you just need a little bit and start getting patterns out of it to start labeling everything else. I think this subset is what's going to really extend the applications of machine learning, right? And we see a lot of work right now in that subspace for computer vision, but I think maybe in another year or two, you're going to see a lot of that being used directly in industry, because the modalities of collecting data are getting better. And we're figuring out a lot of creative pipelines to get data. Now it's about labeling them and then using that for a supervised model. And I think self-supervision will aid a lot of that.
Mm-hmm. What fascinates you the most about artificial intelligence?
Ooh. Man, this may not be a popular answer, but what I like about it most is that you could be an industry expert in something, right? So for example, I used to work with this very talented oncologist at Mount Sinai, and he's a very smart doctor, right? And he's had, I think, close to 30 years experience. He's seen so many different instances. And then the reason we're working for him, we basically had not to go into details, but we basically had a model that would take in inputs from his patients, and it would predict something. And initially he was like, why do I need this? I've seen everything in my 30 years of lifetime, and I know what it should be. And by the way, for health, it's not one output. A lot of times it's called differential diagnosis. They'll output 3 or 4 possibilities, and the doctor will go in and do detailed tests for the 3 or 4. It's never just like one output. It's not deterministic like that. But so our model would try to do the same. And after getting a lot of the data, because we had the relationships with other facilities, we were able to show him the product, and it had interpretability pieces. And even after 30 years, being able to see something that the model has done, you both saw the same, the doctor and the model had the same input information, but the model, produced something that genuinely surprised him because it was a small part of a scan that he happened to miss, right? It was able to pick it out. I think that augmentation was very magical to me. Being an expert as you are, AI lets you combine the expertise of many experts, and you all get to leverage it. And it's even better when it's not making the decision for you, but rather supplying additional information for you. So I think that's the coolest part of AI for me. The ability to augment what we already do using the expertise of the people that are in our subfield. I think that's worthy of calling it a super innovation. It's something, a tool that can just augment what you do based on other people like you. It's fantastic. And it's not just health. My example is in health, but we see it everywhere. Design, right? Designers, writers now. The tools that are coming out now for computer vision and being able to manipulate images, it's gonna fundamentally change the design industry and content creation, right? That aspect is my favorite. And some of the things that the models are doing, especially for computer vision, it would take years if we need to actually code out the mechanisms to do this, right? There was this de-occlusion paper where, I take a picture and each item has been de-occluded and isolated. So now I can move an item in a page or in a picture. I can move it around, morph it. The ability, if you actually had to code that and build it out like that, different shapes, different shadows, different for everything in the world, that would take forever, right? So being able to create generalized approaches to do that, that's a fantastic capability of AI. And there are flaws too. You're not going to be able to generalize well for everything, but computer vision and NLP, we're starting to develop more generalized structures to tackle most of the issues. So I think that's probably those are my favorite aspects of when it comes to machine learning.
Okay, cool. What keeps you awake at night, Goku?
Ooh.
Do you think a lot about the future of AI, or are you like, okay, I'm living in the here and now, and we have the tools available, and I'm focusing on now, what we can do now?
Yeah, I try to focus on the now, but it's impossible not to think about where it's headed. I can talk a lot about the US, right? So when it comes to I'm sure a lot of countries are like this too, but when it comes to the US, all the really, I may get bashed for saying this, but all the really influential work that's going into production, I'll phrase it that way, all the work that's going into production is done by companies, right? Large companies, small companies, which means they have the data, which means they continue to make improvements. So sometimes monolithic companies, search platforms, ad platforms, they have all this data, and they're the only ones that get to use it and make developments to it. And any open source data that you hear coming from the monolithic companies, those are strategic releases of data, by the way, right? No one's ever just going to give you their useful data for free. So I think my worry is that these silos are becoming bigger silos, right? I think there needs to be some kind of democratization when it comes to data, especially data that I'm generating, right? My search, my browser activity, my activity in my car. I should have access to that data, and I should have access, or at least the capability to give you that data to use it for something. And the reason I say this is alarming is because these silos are getting bigger, and because the applications they're developing are for their benefit, it's kind of like a closed loop, right? Anybody that wants to come later and use the data to make something slightly useful or competitive, even it's impossible, right? So there's it kind of thwarts competition. It kind of I think it kind of hinders capitalism too. But that kind of worries me. The other aspect is I think there's too much focus right now on when it comes to industry applying to the bottom line, and I would say nearly 100% of the world's bottom lines, except for a few, good companies, it's about money, right? It's about selling more phones, selling more ads. So all the machine learning that's being developed right now, including the cutting edge research, even though the research may be on some health data set or climate change data set, the technique will be leveraged on some finance data set or some advertising data set, right? So I think what I'm asking for is, yes, unfortunately, you need to join those companies because they pay well. And most of the companies work on that kind of stuff. But I think I would release the message and say, I think we should have people start to think about other world issues as well. There's a big movement right now. Actually, at certain conferences, they even have specific focus groups for climate change, for specific health fields, for wildlife safety, wildfires. So work on some projects that are more civic and social as well. And maybe in another 5 or 10 years, there are more people focusing on these more important issues. You'll be able to get a really good job, and that focuses on one of these things too. So I think as a society, putting more focus on getting data for these more worldly problems, civic problems, is important, and I think it's severely unnoticed right now. Very few people are working on things like climate change for AI. I could name them in one hand, right? So I think that needs to change. That does keep me up at night because not sure if a lot of people believe in climate change, but I think it's a real problem. We're seeing changes already on our planet. So for areas like this, we need to focus on that, right? We can't just continue to plummet all of our talent resources on things that make money.
Yeah, absolutely. The last question I want to ask you is, what advice would you give your younger self? Even if you were much younger, like you're young, I guess, but if you were much younger.
Oh man,
doesn't have to be about AI.
Yeah. I think I say this a lot to my family actually, because I have a little brother. We have a big age gap. I think he's 16, and I talk to him regularly, and his mind is always about games or getting test scores, right, and things like that. I look back and I say, I just wish I realized all the school that I went through, all the college, just focus on fundamentals. I think as a whole right now, whether you're from the best college in the world or the worst college, in terms of fundamentals, very few people have the solid fundamentals. And when I say fundamentals, I mean math, physics, chemistry, and a certain amount of biology. These four subjects, I think if you can get the foundation in high school or college, that literally sets you up to do anything in life. Because everything is derived from this, right? You need to learn a bit more, but everything starts with this foundation. And I wish I had a better foundation. I still learn about a lot of these topics now because I forgot or I didn't get I didn't learn it the right way. So I keep going back to it, but I think in another 4 or 5 years, I may just take off another year and just get the foundations properly set again. But I wish that's what I used my college life days for. Instead of focusing on tests or even a specific industry that I'm trying to excel, which is good, getting the foundations right. I think that's going to be the focus. Another thing I always talk about with people, every year there's more and more research. So someone asked, is school going to get longer? Are we going to have more years of college or more years of high school? No, because it's going to get the foundations that we learn, they're going to get better, as in it's going to become easier to learn them through mediums, right? Different mediums. And once you learn that, then you specialize earlier. I think that's what's going to happen. So my advice would be to get the foundations and then specialize after that. But it's never too late. It's just like computer science. There's great resources for giving yourself a proper foundation in all of these areas, right? Especially math and physics online. I think there's a great math physics community on Twitter. Everyone's creating animations and things like that. It's great to learn from that stuff. So it's never too late to give yourself a foundation. And, if you're working, if you have kids, mortgage, whatever it is, just spend an hour or two a day, but make it a habit, right? If you're in college, you can spend many hours a day, but if you're working, do an hour or two a day, make it a habit, and you'll get there. The learning compounds every day. So a year of solid learning like that's going to set you up really well.
Okay, cool. That's a perfect closing, Goku. Thank you so much, by the way, for participating in the podcast, and I'm looking forward maybe to a second part.
Absolutely, yeah.
Where can people find you?
Yeah, so I mostly on Twitter.
Mm-hmm.
So my personal handle, we can link it, but at Goku Mohandas. And then definitely check out Made with ML if you are thinking about learning machine learning, or if you're already in the industry. It's great for keeping up to date. Great for, as we talked about earlier, not reading everything, but allocating it, putting it in collections. And then it's a great community. I think we're able to share a lot of people's work, both popular and work by fantastic researchers from lesser known places. So it's www.madewithml.com. And then we're also on Twitter and LinkedIn, Made with ML, where we put daily updates on the best content and the new features and things like that. So yeah, those are the things you can follow.
It's amazing. If you do any videos in the future, do you have a YouTube channel and planning?
I do. So I think you need to, I don't know if there's a name for the channel, but if you search YouTube, or if you go on madewithml.com, in the bottom, there's a YouTube thing. You click on it and follow. Yeah, we're going to put the first video up in probably 1 or 2 weeks. But it's how to make a full end-to-end end-to-end project. Mm-hmm. From the idea to the code to the final demo that you need to put together, because you need that these days. So I'm going to show that end-to-end using the best free tools to create that. But I'll have more ML videos sort of teaching like how you are, Yusuf, on various concepts soon.
Sounds cool. Maybe we can collaborate in the future. Let's see.
Yeah, that'd be awesome, actually. That'd be very cool.
Thank you so much again, Goku, and see you on Twitter, I would say.
Yeah, thank you, Yusuf.
Bye-bye.